what do you use the timeline to where we achieve AGI, aka powerful AI, aka super useful AI?
Useful. I'm going to start calling it that.
It's a debate. It's a debate about naming. On pure intelligence, it can smarter than a Nobel Prize winner in every relevant discipline and all the things we've said. Modality, it can go and do stuff on its own for days, weeks, and do biology experiments on its own. In one, you know what? Let's just stick to biology because you sold me on the whole biology and health section. That's so exciting I was getting giddy from a scientific perspective. It made me want to be a biologist.
It's almost, it's so, this was the feeling I had when I was writing it, that it's like, this would be such a beautiful future if we can just make it happen, right? If we can just get the landmines out of the way and make it happen. There's so much beauty and elegance and moral force behind it. If we can just, and it's something we should all be able to agree on, right? Like, as much as we fight about all these political questions, is this something that could actually bring us together? But you were asking when we get this?
When do you think? What's just putting numbers on?
So this is of course the thing I've been grappling with for many years, and I'm not at all confident. Every time, if I say 2026 or 2027, there will be like a zillion like people on Twitter who will be like, AI CEO said 2026, 2020, and it'll be repeated for like the next 2 years that like this is definitely when I think it's going to happen. So whoever's excerpting these clips will crop out the thing I just said and only say the thing I'm about to say. But I'll just say it anyway.
Have fun with
it. So if you extrapolate the curves that we've had so far, right? If you say, well, I don't know, we're starting to get to like PhD level, and last year we were at undergraduate level, and the year before we were at like the level of a high school student. Again, you can quibble with at what tasks and for what. We're still missing modalities, but those are being added. Like computer use was added, like imaging was added, like image generation has been added. If you just kind of like, and this is totally unscientific, but if you just kind of like eyeball the rate at which these capabilities are increasing, it does make you think that we'll get there by 2026 or 2027. Again, lots of things could derail it. We could run out of data. We might not be able to scale clusters as much as we want. Like, maybe Taiwan gets blown up or something, and, then we can't produce as many GPUs as we want. So there are all kinds of things that could derail the whole process. So I don't fully believe the straight line extrapolation. But if you believe the straight line extrapolation, we'll get there in 2026 or 2027. I think the most likely is that there's some mild delay relative to that. I don't know what that delay is, but I think it could happen on schedule. I think there could be a mild delay. I think there are still worlds where it doesn't happen in 100 years. The number of those worlds is rapidly decreasing. We are rapidly running out of truly convincing brocklers, truly compelling reasons why this will not happen in the next few years. There were a lot more in 2020. Although my guess, my hunch at that time was that we'll make it through all those blockers. So sitting as someone who has seen most of the blockers cleared out of the way, I kind of suspect, my hunch, my suspicion is that the rest of them will not block us. But look at the end of the day, like, I don't want to represent this as a scientific prediction. People call them scaling laws. That's a misnomer. Like Moore's law is a misnomer. Moore's law, scaling laws, they're not laws of the universe. They're empirical regularities. I am going to bet in favor of them continuing, but I'm not certain of that.
So you extensively describe sort of the compressed 21st century, how AGI will help set forth a chain of breakthroughs in biology and medicine that help us in all these kinds of ways that I mentioned. So how do you think, what are the early steps it might do? And by the way, I asked Claude good questions to ask you. And Claude told me to ask, what do you think is a typical day for a biologist working on AGI look like in this future?
Yeah.
Claude is curious.
Let me start with your first questions, and then I'll answer that. Claude wants to know what's in its future, right?
Exactly.
Who am I going to be working with?
Exactly.
So I think one of the things I went hard on in the essay is, let me go back to this idea of, because it's really had an impact on me. This idea that within large organizations and systems, there end up being a few people or a few new ideas who kind of cause things to go in a different direction they would have before, who kind of disproportionately affect the trajectory. There's a bunch of kind of the same thing going on, right? If you think about the health world, there's like, trillions of dollars to pay out Medicare and, other health insurance. And then the NIH is $100 billion. And then if I think of like the few things that have really revolutionized anything, it could be encapsulated in a small fraction of that. And so when I think of like, where will AI have an impact? I'm like, can AI turn that small fraction into a much larger fraction and raise its quality? And within biology, my experience within biology is that the biggest problem of biology is that you can't see what's going on. You have very little ability to see what's going on and even less ability to change it, right? What you have is this, like from this, you have to infer that there's a bunch of cells that within each cell is 3 billion base pairs of DNA built according to a genetic code. And there are all these processes that are just going on without any ability of us as, unaugmented humans to affect it. These cells are dividing. Most of the time that's healthy, but sometimes that process goes wrong and that's cancer. The cells are aging. Your skin may change color, develops wrinkles as you age. And all of this is determined by these processes, all these proteins being produced, transported to various parts of the cells, binding to each other. And in our initial state about biology, we didn't even know that these cells existed. We had to invent microscopes to observe the cells. We had to invent more powerful microscopes to see, below the level of the cell to the level of molecules. We had to invent X-ray crystallography to see the DNA. We had to invent gene sequencing to read the DNA. Now, we had to invent protein folding technology to predict how it would fold and how they bind and how these things bind to each other. We had to invent various techniques for now we can edit the DNA as of, with CRISPR as of the last 12 years. So the whole history of biology, a whole big part of the history is basically our ability to read and understand what's going on and our ability to reach in and selectively change things. And my view is that there's so much more we can still do there, right? You can do CRISPR, but you can do it for your whole body. Let's say I want to do it for one particular type of cell and I want the rate of targeting the wrong cell to be very low. That's still a challenge. That's still things people are working on. That's what we might need for gene therapy for certain diseases. And so the reason I'm saying all of this, and it goes beyond this to gene sequencing, to new types of nanomaterials for observing what's going on inside cells, for, antibody drug conjugates. The reason I'm saying all this is that this could be a leverage point for the AI systems, right? That the number of such inventions, it's in the mid double digits or something, mid double digits, maybe low triple digits over the history of biology. Let's say I have 1 million of these AIs, can they discover 1,000, working together, can they discover thousands of these very quickly? And does that provide a huge lever instead of trying to leverage the, $2 trillion a year we spend on, Medicare or whatever? Can we leverage the 1 billion a year that's spent to discover, but with much higher quality? And so what is it like, being a scientist that works with an AI system? The way I think about it actually is, so I think in the early stages, the AIs are going to be like grad students. You're going to give them a project. You're going to say, I'm the experienced biologist. I've set up the lab. The biology professor or even the grad students themselves will say, here's what you can do with an AI, AI system. I'd like to study this. And, the AI system, it has all the tools. It can look up all the literature to decide what to do. It can look at all the equipment. It can go to a website and say, hey, I'm going to go to, Thermo Fisher or, whatever the lab equipment company is, dominant lab equipment company is today. In my time, it was Thermo Fisher. I'm going to order this new equipment to do this. I'm going to run my experiments. I'm going to, write up a report about my experiments. I'm going to, inspect the images for contamination. I'm going to decide what the next experiment is. I'm going to write some code and run a statistical analysis. All the things a grad student would do, there will be a computer with an AI that like the professor talks to every once in a while, and it says, this is what you're going to do today. The AI system comes to it with questions. When it's necessary to run the lab equipment, it may be limited in some ways. It may have to hire a human lab assistant to do the experiment and explain how to do it. Or it could use advances in lab automation that are gradually have been developed over the last decade or so, and will continue to be developed. And so it'll look like there's a human professor and 1,000 AI grad students. And, if you go to one of these Nobel Prize winning biologists or so, you'll say, okay, well, you had like 50 grad students. Well, now you have 1,000, and they're smarter than you are, by the way. Then I think at some point it'll flip around where the AI systems will be the PIs, will be the leaders, and they'll be ordering humans or other AI systems around. So I think that's how it'll work on the research side.
And they would be the inventors of a CRISPR type technology.
They would be the inventors of a CRISPR type technology. And then I think, as I say in the essay, we'll want to probably turning loose is the wrong term, but we'll want to harness the AI systems to improve the clinical trial system as well. There's some amount of this that's regulatory, that's a matter of societal decisions, and that'll be harder. But can we get better at predicting the results of clinical trials? Can we get better at statistical design so that clinical trials that used to require 5,000 people and therefore needed $100 million in a year to enroll them, now they need 500 people in 2 months to enroll them? That's where we should start. And can we increase the success rate of clinical trials by doing things in animal trials that we used to do in clinical trials, and doing things in simulations that we used to do in animal trials? Again, we won't be able to simulate it all. AI is not God. But can we shift the curve substantially and radically? So I don't know. That would be my picture.
Doing it in vitro and doing it. I mean, you're still slowed down. It still takes time, but you can do it much, much faster.
Yeah. Can we just one step at a time? And can that add up to a lot of steps? Even though we still need clinical trials, even though we still need laws, even though the FDA and other organizations will still not be perfect, can we just move everything in a positive direction? And when you add up all those positive directions, do you get everything that was going to happen from here to 2100 instead happens from 2027 to 2032 or something?